on tonight? What are we doing? Hey, did you send me anything?
Yes.
Let me open it up. I closed out my Gmail for some reason. So you guys are not on spring break this week, huh?
Nope, we get out during Easter.
Okay. Which of these two attachments you want to start with? The one on the left? I don't know how well you can see them.
The one on the left for now.
Okay. Still doing calculus, I can see.
Yep.
Where do you want to start?
Question 17.
Okay. So, you've had your power rule, product rule, quotient rule, and chain rule, I gather.
We haven't done the chain rule yet, actually.
Okay, that's good. That's the only hard one. Everything else is just memorize and plug. Okay. Now, I have a great way for memorizing the quotient rule.
Okay.
Starts with the bottom, ends with the bottom squared. For example,
3
if y
minus
is
2.
u over v, let's assume this one, then here's why that works well. If you start with the bottom, well, the next term has to be the derivative of the top, right?
Mm-hmm.
You know that subtraction is taking place because order counts. It's not like the product rule where order doesn't matter. In the product rule, you can do it either way, right? But in the quotient rule, your numerator has to be in this order. And the only reason order could matter is if you're subtracting. And then the rest of it is going to be the opposite of the first part. So the rest of it's got to be v prime u ends with the bottom squared. So if you start with the bottom and end with the bottom squared, you really can't mess anything else up. In other words, everything else kind of writes itself. As long as you remember subtraction is taking place in the numerator.
Okay.
That's why it's important to start with the bottom. You don't start with the derivative of the bottom. You start with the bottom times the derivative of the top. Okay? So, let's apply this to our function. So, y prime equals, tell me what to fill in. And I wouldn't take any shortcuts at all. When you're doing the quotient rule, I would say the very first step is always to plug it in exactly as you find it. In other words, that's the bottom. Put it in parentheses. What am I multiplying it by?
3x minus 2 squared.
No, the derivative of the top. Here's what, here, let's go back and let me write this again. If I have y as a ratio, then y prime is the bottom times the derivative of the top minus the reverse, which means the derivative of the bottom times the top, all over the bottom squared. So we've got the bottom. Now what's u prime? What's the
derivative? That would be the derivative of the top.
Top.
So the 5 would disappear, leaving the 2x.
Just 2. That's
okay.
The derivative of 2x plus 5 is 2. Now do the reverse. In other words, now take the top times the derivative of the bottom. What's the derivative of the bottom?
3.
All divided by the bottom squared. And write it like this every time. Don't multiply it out. The reason I say that is a lot of times you'll find a factor in the top that is the same as this factor in the bottom, 3x minus 2.
Mm-hmm.
In which case you'd be able to cancel some stuff. Well, let's see what this expands to. In other words, they want you to simplify these. So what's the numerator become?
The numerator becomes 6x minus 4.
Subtracting and still use your parentheses. Whenever you're subtracting something, boy, if you don't use parentheses, you're getting the wrong answer. I'll show you why. What goes in the parentheses?
Negative 2x minus 5.
Well, multiply it by 3. Both
Negative 6x minus 15.
It's actually just 6x plus 15.
Oh.
Now, when I remove the parentheses, it becomes minus 6x minus 15. So the numerator, when I remove the parentheses, becomes this. That's why those parentheses are so important, is that it changes the sign on that last term. You weren't going to make that mistake, but a lot of people do. And then the bottom is still 3x minus 2 quantity squared. Well, simplify the top. What do you get?
That'll be negative 19.
There's your answer. And that's actually the best answer. You don't want to multiply the bottom out. You just don't. And with differential calculus, they don't necessarily want you to multiply that out. Because a lot of times that can be to the 6th power or something, and it would just be a lot of arithmetic and not worthwhile to do.
Okay.
That was 17. 18 next?
Yes.
Okay. So here we have a function in z, and really the secret on these is just to know your general formula, right? So what is z prime?
That would be 3, or negative 3.
Well, give it to me step by step. In other words, if z is u over v, then z prime is v times u prime minus v prime times u all over squared. So that's what I want you to give me is, give me that for starters. What's v times u prime?
It would be negative 3.
Well, that's u prime. What's v?
I believe that's 4.
V is the denominator.
Okay, never mind.
That's why you start with the bottom. Notice that's what I started with, the bottom. And you end with the bottom squared. I'll go ahead and write the ending to this thing. There's the bottom squared. Now, the only thing left is u prime is negative 3, right? Now, remember, the numerator, you need to subtract the opposite. Well, what's the opposite? By the opposite, I mean we're going to subtract v prime u. Well, what's v prime? What's the derivative of the bottom?
3x squared plus x.
What's the derivative of that? Notice what this says for z prime over here on the right.
Okay.
Okay. It says the bottom times the derivative of the top minus the derivative of the bottom times the top. So if I plug it in exactly as these say, well, the bottom is 3x squared plus x. The derivative of the top is minus 3. The bottom derivative is 6x plus 1, right?
Yes.
times the top, 4 minus 3x, all divided by the bottom squared. Well, here's the bottom. If we square it, there you go. That's the layout. That's the step you want to be able to do every time. But in order to do that, you have to have this memorized. But it's not as hard to memorize as it looks. Trust me, if you just memorize, start with the bottom and end with the bottom squared, you really can't screw it up. There's nothing else that can be next to the bottom other than the derivative of the top. And then you're going to subtract the reverse. In other words, now I got the derivative of the bottom times the top. Now, we're not done because we have to simplify the numerator. So let's do that, because you never know what you're going to get. You might end up with a 3x squared plus x in both numerator terms, and then I could simplify it. So give me what that is.
What the top is?
Well, the top left.
Okay, so that would be negative 9x squared minus 3x.
Okay. And then we're subtracting, and I'm going to use parentheses here because they're necessary. Now multiply 6x plus 1 times 4 minus 3x. What's that give you? Go ahead and do it piece by piece, and I'll simplify it later.
Okay, so I would first put the negative in.
Well, let's just there's no negative inside these functions. So don't do that yet. Leave the negative outside and use parentheses.
24x plus 4.
Let's see. We got 24x. It's not plus 4. It's, we got 24x minus, that's a minus, 18x squared plus 4 minus 3x. Okay? Now I can simplify that, and let's make it minus 18x squared. Is that minus? No, that's a plus. I don't know how I got a minus. That's a plus. In other words, 6x times, no, times minus 3x is minus 18x squared. I had it right. And then it's plus 24x minus 3x, so we got a net 21x inside of our parentheses, plus 4. Okay? So that's what that simplifies to. And I left the parentheses on purpose because I didn't want to confuse myself with all these negative signs. Now, remove the negative signs. Still have minus 9x. What I meant was remove the parentheses. So when you remove the parentheses, what are you left with?
So 9x squared minus 3x.
Forget that part. Just remove the parentheses of this part right here. What are you left with? Minus a minus is a plus, so we got plus 18.
Oh, that one I see it. Okay, plus 18x minus 21x minus 4.
Okay. Now I'm ready to simplify. In other words, I don't want to remove those parentheses until I've multiplied those two linear terms together. Just makes it ripe for mistakes. Okay? Now I can combine these. I got a total of 9x squared. I got a total of minus 24x. And I got a total of minus 4. That takes care of all of those. And I still have a denominator. Don't want to forget my denominator, which was the bottom squared. which I believe is that. Yeah. Now, I can't do anything more to that. Even if I could factor the top is a normal looking quadratic, and one might be tempted to try to factor it just to see whether you may come up with 3x squared plus x as one of the factors. Well, obviously you can't come up with 3x squared plus x. And if you can't, there's no point in fooling with the numerator. In other words, if I can't come up with a factor that cancels, there's no point in factoring it. So this is a perfectly fine final answer, unless I made a mistake somewhere, which is always possible, but I don't think I did.
Okay.
Okay?
Got it.
Let's look at 19 next. Should we just doing quotient rules until you're really comfortable with it?
Sure, that sounds good to me.
Okay. So if that's what y is, or they call it g of x, doesn't matter. What's y prime?
Y prime is going to be VU.
Okay. Start with the bottom. In other words, if you memorize the quotient rule, that's all you need. You don't need to write it in terms of u and v. You just need to memorize what the rule is. And the only thing you really need to memorize is start with the bottom and end with the bottom square. So if I start with the bottom, what's the first thing I'm going to write?
X plus 5.
X plus 0.5. Okay.
0.5.
And I know I got to multiply that by something. What would I multiply it by?
Would it be 2?
The derivative of the top.
Would that be 1?
It's 2x. Right?
Is that from the power rule?
Derivative of the top.
Is that from the power rule?
Yes.
Okay.
That's all it is the power rule. And then I know subtraction is taking place because order matters. I can't do the derivative of the bottom times the top minus the reverse. That'd be the opposite order. So what's the next part going to be? The reverse of the first part. Remember what the first part was. The bottom times the derivative of the top. So what's the second part got to be?
Top times the derivative of the bottom.
Okay, there's the top. What's the derivative of the bottom?
0.5. Or no, 1.
All over the bottom square. And it's always acceptable to write it like this. You don't have to ever square it. Okay?
Okay.
But what you do have to do is simplify it. So simplify the numerator. Let's go ahead and put the denominator on there. But what's that equal?
2x squared plus 1x.
Plus x, okay?
Yeah.
And then I'm subtracting that, so I don't need that in the first place. But now all I have to do is remove the parentheses, which gives me what?
Negative x squared plus 4.
Good. Plus 4 is the key. So now simplify that numerator, and let me write the new numerator down here.
Okay, so it would be
Combine those two.
2x squared. It would just be 1x squared, or x squared, plus x plus 4 over x plus 0.5 squared.
There's your answer. And I've yet to ever see a problem where this numerator factors again. In other words, I can tell that doesn't factor, but a lot of times you can't tell instantly whether they factor, and you're tempted to put a lot of time in trying to factor it, because if we could only come up with an x plus 0.5, well, we'd be able to cancel one of these and simplify everything. But I can't. I don't come up with an x plus 0.5 in the numerator if I do try to factor. You can see that you'd have to use the quadratic formula on that, and if you have to use the quadratic formula, you're coming up with irrational answers. You're not coming up with numbers like 0.5.
Okay.
Okay? All right, 20.
Yep.
20 is a little different. 20 looks like it's just the quotient rule on steroids, right? I mean, that's what it would end up being. And that's always the case. The quotient rule always produces extremely complicated answers. Can I do anything to this before plowing in with the quotient rule? I could. In other words, if I apply the quotient rule to this, I'll come up with the derivative. But you'll notice that there's something else I can do first. What is that called? What is that called? Difference of
Squares.
perfect squares. So the top actually factors into t minus 1 times t plus 1. And the bottom factors. The bottom factors into t plus 2 times t minus 1.
Or 1.
Now I can cancel those two, and I end up with something a lot simpler looking that'll be a lot easier to apply the quotient rule to. So what is f prime of t going to equal?
So first would be the bottom and the top.
So tell me what it is. So the bottom is t plus 2.
So that would be 1.
Okay.
And then the top, which will be 1.
Is it minus or plus?
Minus.
Subtraction for sure. What's the rest of the top?
T plus 1 times 1.
All over
T plus 2 squared.
Notice the bottom. Let's see, I don't need that. I got a t minus t. I got a 2 minus 1. Top just becomes 1. All over t plus 2 squared.
Okay.
Okay. Did I do that right? Yeah. Yeah. So sometimes it's well worth, I mean, notice that had I not seen that I could factor, look what you're going to get. In other words, if I don't factor these, here's what I'm looking at. I'm looking at the bottom times the derivative of the top minus the reverse. The derivative of the bottom is 2t plus 1 all over the bottom squared. And look at how complicated that thing is. If I would have done it this way, I'd still be working on it, trying to simplify it. But finding a factor in the numerator that was also a factor in the denominator that let me cancel it simplified everything so much that it really made taking the derivative of it a lot easier. So always look for that, particularly when you see something that looks like there could easily be a common factor. In other words, this factors, that's a real normal one that factors, and that's difference of perfect squares, so we know that factors. So it's really likely that I can come up with a common factor between the two. And I did. It was t plus 1.
Okay.
Which canceled.
True.
Let's see, that was 20. 21. I'm glad they gave you 21. Why? Because it illustrates that you don't always have to use the, oh, you haven't had the chain rule yet.
Nope.
Oh, you do have to use the quotient rule then. In other words, nothing prevents me from using the product rule here. The only thing that prevents you from using the product rule is that you need the chain rule. And if you haven't had the chain rule yet, then you can't do it that way. So the other way I'm going to write this is I'm going to take that and put it in the denominator, like this. Same thing, right?
Yes.
Only now I can use the quotient rule. It's actually easier to use the product rule. The reason I kind of liked this problem when I first saw it was that, it's a quotient rule problem that they're going to let us use the product rule to solve. And the product rule, you will admit, is easier than the quotient rule, correct?
Yes.
I mean, the product rule is just 1 times the derivative of the other plus the reverse. That's it. Whereas the quotient rule is quite a bit more complicated. So I would prefer to use the product rule, but if you haven't had the chain rule yet, then I can't use the product rule. Because in order to take the derivative of that, I need the chain rule.
Okay.
Well, in order to take the derivative of that, I need the chain rule. I don't need the chain rule to take the derivative of the inside, so I'm not going to. Apply the quotient rule. What do we get? That's V. So what does V prime equal to?
So it would be 1 plus t squared.
Okay, that's good. Start with the bottom.
Times 2.
Hold on. What's the derivative of the top?
That would be 1, or negative 1.
Minus 1. Right?
Yes.
Subtract.
That would be minus 1, or no, 2 and 1 minus t.
2t, that's the derivative of the bottom,
Okay.
times the top.
1 minus t.
All over
1 plus t squared squared.
Okay. And these problems always end up with the need to simplify the top. Okay. So what does the top become? Let's see. It's minus 1 minus t squared minus 2t plus 2t squared. Did I do that right?
Yes.
And that simplifies to, I got a minus t squared and a plus 2t squared, so I got a 1
t squared
minus 2t
minus 1.
All
over
over
1 plus t squared
plus t squared squared. And again, it's too bad this isn't plus 1. Nah, still wouldn't work. I was thinking if that was plus 1, then I've got a factor of t minus 1, which is close to this, but it's still not the same. If it's not the same, then there's not any point in doing anything with it. So that's where I end my problem. In other words,
Okay.
if I could have pulled a t squared plus 1 out of the top as a multiplier, then I would do it because I would cancel it with one of these. But I can't. And like I said, I never can. I'm always looking, but I never see where I can do that. So that was 21. 22 is the same problem, right? In other words, I got to use the quotient rule because I haven't been taught the chain rule yet.
Yes.
So
How hard is a chain rule?
chain rule isn't that hard. Here, let me give you an example.
After this problem, we can go on the second picture.
Okay. The chain rule says take the derivative of the outside and multiply it by the derivative of the inside. Well, here's the derivative of the outside. Correct?
Yep.
Times the derivative of the inside, that's what the chain rule says. That's what the derivative of that is.
Okay.
Have you had trig function derivatives?
No, I haven't.
In other words, this is the same as the square root of x squared minus 1, right?
Yep.
If I want to take the derivative of this, what's the derivative of the outside? In other words, the first thing you have to decide when you're using the chain rule is what's the inside and what's the outside. Well, the inside's usually pretty easy to figure out, right? I mean, the inside is this part here, x squared minus 1. So what's the derivative of the outside? Using the power rule.
Square root of 2.
Hold on.
Yeah.
Use the power rule. Start with the exponent. That multiplies. And leave everything else inside the parentheses the same. Subtract 1 from the exponent.
Okay.
That's the derivative of the outside. But I have to multiply it by the derivative of the inside. That being the inside, the derivative of that is 2x.
Okay.
That, using the chain rule, is the way you find derivatives. Now, the chain rule is big because at this point you've had the power rule, product rule, and quotient rule. If you get the chain rule down, you can differentiate any function, no matter how complicated. I could give you a function that make you sick looking at it, but you could still differentiate it using those 4 rules: product rule, power rule, quotient rule, and chain rule. So once you've learned the chain rule, you're done with the rules. That means you can differentiate any function. So chain rule is pretty big, but I don't really want to get ahead of things. You want me to go to the next page?
Yes, just to see.
We got about 20 minutes left.
Okay, then the next page would be good.
Okay. All right. Motion along a straight line.
So number 1 would be the one that I'd be starting off with.
All right. Now I'm just trying to figure out how to introduce this topic to you. A really big principle in calculus is position as a function of time, velocity as a function of time, and acceleration as a function of time. Turns out that velocity is the first derivative of position. And acceleration is the first derivative of velocity, which makes it the second derivative of position. Now, what do I mean by position? Well, let's take a case where we have the x-axis and we have a particle moving back and forth along the x-axis. We'll say it starts there. Okay? And this is actually a function of time, not x. And we'll say that for the first couple seconds the particle moves to the right, then it moves back to the left, and then it moves back to the right. Where does it end up? What is this distance? Called displacement. And what's the total distance it traveled? Which is the sum of all of these distances. In other words, the total distance traveled looks to be at least 3 times the displacement, right?
Yes.
So you've had integration?
I don't think so. The only ones that my teacher assigned is 1 through 6.
These are questions that have to do with integration. And not differentiation. Well, maybe not. Let me look at this a moment. S is the position function. So maybe not. No, we don't need integration for this. These are integration problems, but we don't need it to answer these questions. What they're kind of doing is giving you an introduction to integration. Okay? First of all, at time 0, where does the particle start?
At 0.
Now, plug in t of 0 into this function. What do you get? What is its position going to be?
T of 0?
Well, plug in t equals 0. That's where it starts. What is s if t equals 0?
2.
Okay, so that's where we're starting from. Where do we end? Plug in 2 for t.
4 minus 6 plus 2. So that'd be 0.
Okay. What is our displacement? Meaning, where is our final position relative to our initial position?
Right back where it was. Or no, it's
it started at 2 and ended up at 0, so the displacement is negative 2. In other words, it ended up 2 units to the left of where it started. That's a displacement of 2 to the left, so minus 2.
All right.
Average velocity for the given time interval. Well, velocity is the first derivative of position. So tell me what the velocity function is as a function of t.
Okay. How would I find velocity percent?
It's the first derivative of position. This function they gave us is the position function. So if we want the velocity function, we're just going to take the first derivative of the position function.
Okay, so the for t squared, the derivative that would be 2t, then
2t
would it
minus
be
3.
okay?
Okay? That's the velocity function. They want the average velocity for the time interval. Well, what if we figure out the starting velocity at time equals 0, the ending velocity at time equal 2, divide the whole thing by 2, and that'll give us the average velocity.
Okay.
What's our v of 0 equal to?
Plugging that in, that would be -3.
Okay. What that means is that at the very beginning, this particle is moving to the left at 3 units per time, per second.
Okay.
Okay. In other words, we started here. Our first motion is that way because velocity at time 0 is -3. Minus velocity means you're moving left. Plus velocity means you're moving to the right. What is v of 2?
That would be that would be 1.
Okay. Average velocity is v of 0 plus v of 2, all divided by 2 minus 0. That's how you get an average, is you take the beginning plus the end and divide. In other words, it's, I don't want to say rise over run, but average velocity is the beginning velocity plus the ending velocity divided by how many seconds? Well, this is -3 plus 1 divided by 2. Your average velocity is -1.
Okay.
So that answers, it's interesting that you can answer these questions without knowing integration at all. And yet, the only time I ever see these questions from anybody is when they're just started integration. And I kind of like seeing it like this, that they're leading you up to integration by giving you this problem. Not sure it's really going to accomplish its purpose, but part B, find the body's speed and acceleration at the endpoints of the interval. Well, the interval is 0 to 2. Speed is basically the velocity without, it's the absolute value of velocity. So what was the velocity at 0?
Would it be, was it 2 or -2?
-3.
Okay, -3.
That's velocity. Velocity is a vector. Speed is an absolute value of velocity. So speed at, yeah, I don't want to use S because S means position. So speed, we'll call it, equals the absolute value of velocity. So in this case, it's 3. In other words, it's moving at 3 units per second, just happens to be going in the left direction, but it's still moving at 3 units per second. Now, acceleration is the first derivative of velocity. Well, remember what our velocity function was. The velocity function was 2t minus 3. In other words, the first derivative of our position function is our velocity function. So what's acceleration? What's the function for acceleration?
Would that be the derivative of
first derivative of velocity? So what's
okay? So that would be
what is it?
1.
It's the derivative of that.
Would it just be 1?
2.
How is that? Oh, because it's 2t. Okay.
Let's talk about that. If I'm taking, let's say I have y equals 2t.
Yes.
And I put an exponent on that.
Okay.
Well, the first derivative is the exponent times the coefficient, subtract 1 from the exponent. Well, anything to the 0th power is 1. So that's why the first derivative is 2. In other words, it's just the coefficient. But no matter how you look at it, it's 2. You can apply the power rule if you want. It's still 2.
Okay.
So, hold on. I still haven't figured this thing out yet. Ah, that's the page I was wanting. So the acceleration function is just 2. So there's your velocity function, there's your acceleration function, and they want the velocity at the beginning. Here, what's the question again, Si? Find the body's speed and acceleration at the endpoints of the interval. Well, at the beginning, when, in other words, v of 0 equals minus 3 equals a speed of 3. Well, what's v of 2, the end of the interval?
Say that one more time, please.
What is v of 2? This is v.
Okay, b of 2, that would be 4 minus 3, and that would be 1.
Okay, and that's also the speed. In other words, speed is the same as velocity as long as they're both positive. If velocity is negative, then speed is just the absolute value of velocity. Now,
Okay.
what's acceleration at the beginning point equal to? And what is acceleration at the end of the interval equal to? What's the acceleration at the beginning of the interval when time is 0?
That would be negative 3.
This is our acceleration function right here.
2.
Okay?
So it would be 2 regardless.
Both places.
Correct.
So the answer to the question is the speed at the beginning of the interval is 3. The acceleration is 2. The speed at the end of the interval is 1. The acceleration is still 2.
Correct.
Okay. So we can, let's see, when, if ever, during the interval does the body change direction? Well, if this is my position, our velocity function. Our velocity function was 2t minus 3, right?
Mm-hmm.
What is the velocity going to be when I change directions? In other words, remember what we're doing. Remember what we're doing. We're starting at the point 2.
Correct.
We're initially going this way, and then we're going to go back this way, and then we're going to go back this way, and probably end, we figured we ended at 0. But what's happening at each of these points right here? What is velocity there?
It's 0.
Yeah, you cannot change directions unless you stop first.
Correct.
So if I want to know where this particle or body is changing directions, I let the velocity equal 0 and solve the equation. Well, it's happening at time equal 3 divided by 2. That's where it changes directions, and that's the only place it changes directions. At 1.5 seconds, the thing goes from going to the left to going to the right.
Okay.
Okay? So we can answer A, B, and C without any integration. Okay. That's kind of interesting. Unfortunately, that's about all we have time for.
Okay, that's fine.
But I can do number 2 real quickly if you want me to do it in 2 minutes just to...
Oh, no, I can take care of it. Thank you, though.
We started a little bit late, but all right.
It's all good.
If you're good to go, Taylor, I'll let you go.
Okay, thank you. Have a good evening.
You too.